Hello, we're going to be looking at databases over the next few videos and starting with some of our key terms which are needed to understand this topic. So, a database is just a collection of information that is organized so that it can be easily accessed, managed and updated. Now, that organization is essential to be able to access it and manage it and update it in an easy way. Because if I have some unstructured data like I have here, we've got kind of a random assortment of facts in this box. We've got some names, some ages, some locations, but there is no consistency in how the ages and names and locations are presented. So this is an example of data. It's really an example of information because I have got some context to it. Information is data with context. I do know what they're talking about here, but it's definitely not a database because it's nowhere near structured enough. So here is a super simple example of a database. Databases are typically seen as tables, just a collection of tables. And here we've got one table where actually the data has been extracted and organized so that I could quite easily write a program which can interact with this data. I could easily sort out the ages and find out where they live, whereas I couldn't really write any code which can process the unstructured version on the left-hand side. A table is representing data about multiple related entities. An entity in database language is just anything I can store data about. Here we're talking about humans, but it could also be really any real life object, also any virtual object. I might be storing high scores, might be storing error messages, I could be storing anything really. A table has got rows and columns. A row in database language is called a record, and a column is called a field. More formally, a field is representing a single attribute of an entity. So an attribute being like a property. We've got names, we've got locations, we've got ages, we've got many more properties we could store. It's a single example of a attribute. And a record is therefore just a collection of field values for a particular entity. So James is an entity, he's got a name James, he's from Crewe, he's 17. Now this little example here is an example of a flat file database, which is a database consisting of only one table. Now flat file databases are used. We'll look at an alternative in a minute or so, but we do occasionally have to just store one table at a time. So if you're only ever storing data about one group of entities, it is sensible to have a flat file database. If we're just storing it about these different people and their locations and that's it, sure, have one table. And if you're not storing much data, also it might be appropriate to have only one table. Now, because flat file databases are quite simple, they're the simplest database we can have, it's just one table. If you only have non-specialists working on this database, you might have to use a flat file database. And lastly, typically we can create flat file databases in really, really simple programs like Notepad, for example. Here is a CSV file, which is effectively a flat file database. I've got 3 columns, they're separated by commas. Very simple. Safety for this high score example may not be super important. There are no other safety tools built into this program, and so therefore a flat file database may be suitable. So here are just some reasons which you may be asked to evaluate in an exam, but quite honestly, we rarely use flat file databases if we're storing a large amount of data because they are really inefficient, and we'll look at why a bit later. So the types of databases we do tend to use, and we'll be talking about a lot more, are relational databases, which have multiple tables, and they are linked together through something called key fields. So more than one table, and the tables have some sort of connection to each other. So let's say I'm storing data about a school. First of all, I might want to store data about teachers, and because I'm going to have multiple tables, we now have to give tables a name as well. So the table is called teachers in this example. I've got 4 fields, and I've got 4 records. So what is a key field? Well, a key field is, as the name key suggests, a really important field. We've got a few types of key fields. The most important arguably is a primary key. So a primary key is a type of key field that is unique for every record in the table. So the value in the primary key must be unique for every single record. And if you look at this table here, only teacher code is unique for every single record. So therefore, our teacher code has to be our primary key. And the person creating the database will designate a column as being a primary key, and it must be kept unique. Here is another table called classes, and we can start to see what it means to be linked together. Because teachers have got classes, they are linked in real life. So how do we model this in a database? What we do, we have to add in another type of key field called a foreign key. So a foreign key is a field in one table but is a primary key in another. So classes does have its own primary key. Every table must have a primary key. The most likely primary key here is probably going to be name in classes, but it's also got a foreign key. So the foreign key happens to be a primary key in another table. And this allows us to effectively look up information across both tables. If I want to see what classes ABN has, I can go into the classes table, look for ABN in the teacher code field, and find what classes that teacher has. Likewise, I could find out, oh, RHG, who is that? RHG, turns out it's Miss Holding. I can look that information up by using this foreign key. A foreign key won't be unique. It almost always won't be unique because we use it to look up multiple values. So why should we use a relational database in most cases? Well, really, it's the opposite of all of the points I made about flat files, but there are another couple of points which are important to understand at this stage. So flat file databases can end up having lots of what we call redundant data. Redundancy within a table is a really bad thing. Redundancy means we've got something repeated unnecessarily or something which isn't needed, and that just wastes storage space, essentially. So here what I've done is packaged all of the same information into a single table to make this a example flat file database. And we can start to see some issues in this table. You can see we've got some awkward gaps on the bottom left, which could be a problem, but the bigger problem potentially is this redundancy in the top right, where we've got Mr. Brown in twice, computing in twice, 19 in twice, and this is only for 2 classes. If a teacher had, say, 10 classes or 15 classes, this would be repeated 10 times or 15 times. And that's just redundancy. We don't need this data. We're wasting our storage space by putting it in here. And this happens in a flat file database because I'm not separating out separate entities. Now, also another issue is really a slight side effect of having redundancy. And this is that if you've got data which is repeated unnecessarily, it's more likely that we have inconsistencies starting to be introduced. A lot of the time you've got someone manually typing in these values into a computer. And if they're having to type in the same values multiple times, we get things like typos, we get slight changes in how things are typed in, we get, mistakes getting made, we get different formats. And that makes it really hard to search because you now have multiple values which mean the same thing, but represented in different ways. So we don't want any redundancy at all really in a database, mostly for storage space, but also because we don't want to have any inconsistencies creeping in to our database.